Hi, hello viewers. This video is going to be about a revision video about Newton laws of motion part 1, which is without friction. As you know, JEE 2024 is approaching. In hardly 4-5 months we have this exam. So I am going to make a complete conceptual videos. Conceptual. What are the concepts that are required for this chapter? We'll discuss concepts in this video. This will be like a one-shot video. Okay. So let us see what are the concepts that are involved in NLM 1, which is Newton laws of motion 1. So as you know that force is defined as, if I take Newton's second law, it says that F net is equal to ma. This is the first formula that we have to know. What do I mean by F net? Suppose if I take a block, I should know what is the net force acting on the block. So let us say here 20 Newton's force is acting and here 14 Newton's force is acting. So in x direction, what is the net force that is acting? It is 20 minus 14, 6 Newtons. So this F net is actually this. We have to find out the net force on the object. Okay. So from there we can find out what is the acceleration on the block. So this force is also defined as rate of change of momentum. Momentum means mass into velocity. Okay. So momentum is a vector actually. So force is also a vector. So momentum, whenever you are calculating, you should consider the direction also. So let us take first example. So let us say there is a wall and a ball is going with a momentum, let us say mv, towards the wall. After it hits the wall, it rebounds. So is the ball creating any force on the ball? The ball is creating a force on the ball. So for that, what we have to do? We have to use this formula. Okay. So here what we do? We have to find the change in momentum. So the change in momentum would be like dp would be like final momentum minus initial momentum. So I will consider this direction as positive. So the final momentum, which is in this direction, I have to consider that as negative. So minus mv by t. It is 2 minus 2 mv by t. So this is the force that is acting on the, that has been acting on the wall. Okay. So in this, let us see the next case. So this time what I will do is, I will hit the ball in an angled way. Okay. Now this is in 2D now, 2-dimensional. So this is the momentum of the ball and this mv is the final momentum of the ball. Let us say it is making theta angle. So in this type of problems, what we have to do is, we have to resolve this into components. So it will have two components, horizontal and vertical. Okay, we have to resolve them. So because this is theta, this is also theta, this will be mv cos theta and this will be mv sin theta and this will be mv cos theta. So if you are calling this as positive, this has to be negative and this will be mv sin theta. This is mv actually. So this is also theta. So here what we have to do is, when we are finding the change in momentum, we have to find in direction also. So let us find out what is the change in momentum in px direction. In px direction, so this is the initial and this is the final. As argued in the previous case, you will get here 2 minus 2 mv cos theta. Okay. Now let us find out what is the change in momentum in the y direction. You can see here both are in the same direction, initial and final. So delta py will be equal to 0. So delta p would be equal to delta px square delta py square under root. This is your parallelogram law formula. So here you will get 2 mv cos theta. Correct. So the force would be delta p by t, which will be 2 mv cos theta by t. So let us move on and see some more concepts. So we have seen the angled case also. Now let us say what happens is, suppose there is a circular motion, okay, and the object is here. Here it has a momentum p, and it reaches here after certain time, and the momentum here is p. Let us say the object is going with v speed, okay, the object is going with v speed. So this is the center and theta is the angle. So if you want to find what is the change in momentum in this type of case, what you have to do here, we have to apply this vector rule only. So let us draw it. Let me draw this vector. So this is like this, p vertical, and this is like this, you know, you have to back extend it. If you extend it, this is like this, okay. So we have to find this theta now, actually this angle, actually what is this angle. So this was the circle center, so you have to join them. So this is theta, and because this is tangent, so this would be 90 degrees, okay. So this will be 90 minus theta. So this line and this line will be parallel to each other, so this angle will be 90 minus theta. So this is also p. So we have to find the resultant of these two vectors. So the resultant of these two vectors, basically what we are doing here is, we are finding the change in momentum, no? So we have to reverse this. So this is positive p, this will be negative p. So we have to take this angle actually, which is 90 plus theta. See, basically what we are trying to find is, we are trying to find delta p, which is p final minus p initial, okay. So let us find out PR. So now we have the angle between them. Now we have to find out what is the resultant of this. So the resultant would be p square plus 2p into p cos of 90 plus theta, cos of 90 plus theta, okay. So if you simplify this, so p square will come out, so this will be 2 plus 2 into cos of 90 plus theta. So this would be like p into root over 2 into 1 minus this, sorry, here plus will be there, okay. So this will be cos of 90 plus theta will be sin theta. In the second quadrant cos is negative, so it will be minus sin theta. So this is the change in momentum in this particular case. Let us just check out the angles whether we have taken properly or not. So this vector I have drawn here, and this vector is here, so we are just back extending it. We just want this angle. So in that situation, this is theta, and we have taken the first vector here. So this will be 90, okay. So this will be 90. So this will be 90 minus theta. So this will be 90 minus theta, and this will be 90 plus theta. So fair enough. We are getting p into under root 2 into 1 minus sin theta. So this is how we can find out the change in momentum in a circular motion. So let's move on to some other concept now. So the next concept is, sometimes what they do is, they will take a plate, let us say this mass is m, and they will fire bullets towards it, and let us say n bullets are fired in t time, okay. Now by firing these bullets, each bullet mass is m, okay, and now they are able to hold this plate in air. So basically what is happening is, these bullets are going and hitting this plate. So those bullets will be imparting a force on the plate. So let us say I am taking the case that the bullets are rebounding, okay, the bullets are rebounding with same velocity v. So they are hitting and coming back with same velocity v. In that situation, what happens, this if you try to apply this equilibrium condition, this weight mg will be acting downwards, and it will be balanced by the force of the bullets. So fb will be equal to mg, okay. Now how do I find fb? So fb is created because of the momentum which is imparted by these bullets on the plate. So that we can write it as 2mv. There are n bullets fired each second. So this will be the force on the plate, that is equal to mg. So from here we can find out what is the speed required with what speed the bullet should be fired to keep the plate in equilibrium. Suppose in the same case, this let us say the bullets were hit and the bullets are not rebounding, then that situation what happens, the rebounding speed will become 0. So this 2 will not be there. Then the force will become, Fb will become mvn by t, because pf minus pi, this p initial will be there but p final will not be there. So in the place this 2 will not be there, rest all calculation will be same only. So this video is purely conceptual. I am not discussing any problems as such in this particular video. All the main concepts which are usually tested, I am discussing that only. If the video becomes slightly lengthier, then maybe I'll add another part to it. So the next concept is the concept of impulse. See, impulse is like, F is equal to dp by dt. So F into dt, this is called impulse. This is represented by j vector, which is equal to change in momentum. Okay. Now where exactly this impulse type of situation comes means, let us say in a cricket field, a bowler is bowling at 150 km/h speed, and the batsman is there, okay, and the batsman hits the ball. So actually, in reality, the batsman gets only 0.4 seconds time. So a huge amount of force is imparted on the bat actually. Okay. So here exactly what happens is, the ball goes and hits the bat and it rebounds. Let us say it rebounds with the same speed. So in that type of situation, impulse will come into picture, because the operational time is very, very small. Operational time is very, very small, delta t, 0.4 seconds. So how do you find that means? So the force imparted will be actually equal to change in momentum. Here it will be 2 mv, okay, divided by delta t. So F into delta t is equal to 2 mv. So you can count this as impulse or this as impulse. So it has a direction also. The final direction is in the minus x direction. So there is an integration formula also for impulse. Impulse is also given by integration of f of dt. Okay. So let us see a small problem on this. So in a particular example, I'm going to flash this question also on the board. You just go through the question and then we will discuss. In this particular question actually, we have to find the impulse, and if you look at the question, the force is given as f dt, integration f dt. The force is given as a plus btj into dt, and you have to integrate between the time limits. What is the variable here? T is the variable here, between 0 to 0.3 seconds. T is equal to 0 to t is equal to 0.3 seconds. So let us integrate this. So the value of a is given as 2. So this can be simplified as 2 plus 4t dt from 0 to 0.3. Okay. So this becomes 2t and this becomes 4t square by 2 from 0 to 0.3. So if you simplify, this becomes 2 into 0.3 and this is 2t square, so it is 0.3 square. So it is 0.6 and this is 0.09. So 0.6 plus 0.18, it is 0.24. Now the main point is, how do I know in which problem I should apply this type of integration formulas? See, always look for the clue. So here force is not a constant force, this is a variable force, okay. It is a function of time. Remember, whenever you find any equations which are function of time, you always think in terms of calculus. This is the trick. These are time varying functions actually. So whenever you see these type of functions, always think that can I apply any integration formula here or a differentiation formula here. So these cannot be solved by a normal methods actually. You have to apply the calculus approach. So this is about impulse. So impulse you are going to apply whenever you find small time intervals. So think always in terms of impulse. So now let us next discuss about Lami's theorem. Lami's theorem. What is this Lami's theorem means? Suppose three concurrent forces are there, okay, which are mutually kept in equilibrium state, okay, and these are the angles. The total angle will be 360. So these are kept in equilibrium. These are three concurrent forces. These are coplanar forces. So here one condition is there that F1 by sine theta 1 is equal to F2 by sine theta 2 is equal to F3 by sine theta 3. This is the condition you can apply whenever you find three concurrent forces. This is the Lami's theorem. So let us have a look on inclined plane problems also. How do we resolve the forces? So now we will see inclined plane problems. How do we resolve the forces actually? So I am taking an inclined plane, making angle theta. There is a block here, okay. So what are the forces which will act on this? This is mg. So remember this angle will be theta. We can derive this also. So why that angle is theta? So this is so this is theta, this is 90, this is 90 minus theta, this total is 90, so this will be theta. So this component will be, this is adjacent component mg cos theta, and this component will be mg sin theta. Besides this, there is a normal reaction which is acting here, okay. So these are the forces which are acting on a inclined plane. So let us see one small problem on this. See, so let us say I'll apply a force P here, and this block mass is m. So m is acting, mg is acting like this. This is theta. So this is mg cos theta, and this is mg sin theta. This is normal. All right. So let us say the block is in equilibrium in y direction. I am calling this as x and this as y. So x and y you can take as per the problem. X and y should be selected in such a way that your your calculations become more easy. So in this situation, I can say sigma fy is equal to 0. Now this is the equilibrium condition I am applying in equilibrium in y. Okay. So n is balanced by this force. So n is equal to mg cos theta. Coming in the x direction, suppose this is equilibrium case. So this is balancing this force. So I can directly write P is equal to mg sin theta. So this is equilibrium condition, okay. This is equilibrium in x. That means I have taken sigma fx is equal to 0. Now let us say this force is bigger than this force. Then what will happen is there will be a net motion going on in this direction, in the upward direction. So in that situation, F net will be equal to P minus mg sin theta. This is F net, which is equal to m into a. So here you can find out what is the acceleration of the block, P minus mg sin theta divided by m. That would be the acceleration of the block. Okay. So in this I am going to take another condition, and we will take the components of that and we will resolve and see what happens. Now here let us say the same situation, this is the block, and this time the force is acting like this, okay, mg is acting like this, theta is like this. So what are the forces which are acting here? So this is theta, so this is mg cos theta, and this is mg sin theta. This is your normal reaction, and as usual I am considering this as x and this as y. So here what we have to do is we have to resolve this p force in appropriate direction. So p also will have two components now. It will have one component, if this is theta, this line is parallel to this, this is also theta, so this will be p cos theta, and here one component will be there which will be p sin theta. That's it. So again applying the conditions, that is equilibrium in y, sigma fy is equal to 0. You can say n is balanced by these two. So n would be equal to, n is the normal reaction. Normal reaction will come into picture only if the block is in touch with the ground. Otherwise there is no question of any normal reaction. Normal reaction is equal to p sin theta plus mg cos theta. Okay, so this is the normal reaction, and let us say we will find out in x direction. So x direction, what happens is, now you have to consider this component instead. In the earlier case you have taken the direct force, now you will consider the component. So in this situation, suppose p cos theta is more than this, so p cos theta minus mg sin theta, that would be your F net, which will be equal to your mass into acceleration. Which mass? This mass into acceleration. So here acceleration will be equal to p cos theta minus mg sin theta divided by m. So like this we make the calculation for simple cases. So next I am going to discuss about in this we are going to discuss about the free body diagrams. I am going to discuss about apparent weights, apparent weight calculations, apparent weight. See, you have many times come across as FBD. FBD basically means, so suppose if I am taking a block which is resting on the ground, you have to just identify what are the forces which are acting on the block, and you have to just write them. So in the vertical direction weight will be acting, in the vertically downward direction, in the upward direction normal reaction will be acting. This is called separating the forces, this is called free body diagram. So we are going to study about apparent weight. What is the concept of apparent weight? See, apparent weight is like this. Suppose there is a lift, okay, there is a lift, and there is a weighing machine on the lift. There is a person who is standing on the lift, on the weighing machine. So we are interested in knowing what is the reading that will be shown in the weighing machine. We will take a couple of cases here. Initially the lift was at rest. So when the lift was at rest, what are the forces which are acting? The man's weight mg will be acting down. The normal reaction which will be exerted on the weighing machine, it will be in the upward direction. So n is equal to mg. So in this situation you are going to observe true weight. You are going to see true weight. The reading will be correct actually. Suppose you take further cases that the lift is now accelerating in the upward direction. The lift is accelerating. So let us write the forces now. So this is a normal reaction. mg is acting down. Now because the lift is accelerating in the upward direction, which force must be bigger? This force must be bigger. So this force must be bigger than this. So this is n minus mg will be equal to nm. Suppose you don't understand this. Suppose here 14 newtons are there, here 10 newtons are there. Which force is bigger? This one. So the block will go in the upward direction. Here only symbols we have put. So n is equal to mg plus ma. If you rearrange the terms, it will be mg into 1 plus a by g. You will see more reading in the weighing machine. Okay. So the next case is, so this is the formula also you can remember. When the lift is going up with an acceleration, you will see more reading in the weighing machine. Suppose the lift is going down. The lift is going down with the acceleration. Alright. So now the lift is going down with acceleration. Draw the free body diagram. N will be in the upward direction, mj will be in the downward direction. Because the lift is going down, this force will be more than this net force. That is why the lift is going down. So mg minus n is equal to ma. So n is equal to mg minus ma. If you take mg common, it will be 1 minus a by g. So in this situation, the lift, the reading will be less than the true weight. Actually what happens here is, if you can maintain a is equal to g, the reading will become 0, the man will feel as if he is weightless. In this, I want to tell a very important point, that when the lift is accelerating only, you have to use these formulas. If the lift is going with constant speed, the concept of apparent weight is not applicable. Okay? So usually this tension in the string calculations are usually asked. So let us see couple of cases in that. Okay. So I'm going to take up a case, this case. Okay. So there's a mass here and there's a pulley and one mass m2, mass m1. I'm assuming that m2 is more than m1. I'm assuming that the string is almost weightless, the pulley mass is ignorable, and we are trying to find out what is the acceleration in the system and what is the tension in the system. So because the string is same, we will write same tension here, right? And because the string is same, each point will be having same acceleration. So let us write the free body diagram for the first one. Because this weight you are considering more, the system will accelerate in the downward direction, this will accelerate in this direction. So let us write for this case. So m2g will be acting down, t will be acting up. So this force is more, that's why it is accelerating down. So m2g minus t is equal to m2a. Net force is equal to mass into acceleration. So this will be my equation 1. Now let me apply the free body diagram concept on the first mass, m1. So here only one force is acting. That means you have to cut a section here and you have to see what are the forces which are acting on the block. Okay. Then why did I write equal and opposite here? Because if you see the system as a whole, the tension will be equal and opposite. Tension is basically an internal force. It is basically an internal force. Okay. So when you are taking a block and applying a force, this is external force. Okay. But tension is an internal force in the system. So in this situation, the net force will be T itself, which will be equal to m1a. So this is my equation 2. Because there are no other forces which are acting here. So using this we can find out what is T and what is EA. If you simply add 1 and 2, you are going to get, if you add 1 and 2, T will be eliminated. So you are going to get m2g is equal to m1 plus m2 into a. So a will be equal to m2g by m1 plus m2. Because you have found out what is acceleration, we can find out what is tension also. So tension will be equal to m1 into a, m1 m2g by m1 plus m2. Okay. So let us see one small problem in this type of problems. A system is given like this. Okay. So there is a mass here and one pulley is kept and another pulley is kept. So there is a mass here 2 kg and there is a mass here 1 kg and this is 3 kg. Okay. And you have to find out what is the acceleration of the system. Now here you have to identify what are the forces which are acting. So here, because this string is different, I will call T1 is acting here and T1 is acting here. Now this string is different, we will call T2 is acting here and T2 is acting here. So first of all, because 2 kg is more than 1 kg, there is more likelihood that this will go down and this will go up. Okay. Now for practical, because number of unknowns will increase. We are assuming that the whole system is going with the common acceleration a. Alright, so let us draw the free body diagram for this one. So this is 20 and t1. So 20 minus, because this is accelerating downwards, 20 minus t1 is equal to 2 into a. This is my equation 1. If you draw the free body diagram for this block, it will look like this. So t2 here and t1 here, and this is accelerating in this direction. So t1 minus t2 would be equal to 3 into a. This is my equation 2. Now let us write for this block. Okay, so 10 downwards, t2 upwards. Okay, and this is going in the upward direction. So we can say t2 minus 10 is equal to 1 into a, which is a. Now I got 3 equations, 3 unknowns, so we have to solve for them. So how can we do means, we can do one thing, that we can add these two equations, then t1 will be eliminated. So I'm going to get, so 20 minus t1 gone, 20 minus t2 is equal to 2 plus 3, 5a. And now I can use this equation and this equation. I can add these two, then t2 will be eliminated. 20 minus 10, this will be 10. 5 plus 5a plus a, 6a. So a will be equal to 5 by 3. So once I get the a value, I can substitute here and get the remaining values. So you can get the t1 value here. 20 minus t1 is equal to 2 into 5 by 3, which is 10 by 3. So 20 minus t1. So t1 would be equal to 20 minus 10 by 3, which is 50 by 3. And similarly t2 also can be obtained from this. So this would be 20 minus t2 is equal to 5 into a, which is 5 into 5 by 3, which is 25 by 3. So t2 would be equal to 20 minus 25 by 3, which is 60 minus 25 by 3. I think this is 35 by 3. So like this you have to solve for the unknowns in this type of problem. We can do one more inclined case in this actually. So suppose sometimes it may be given like this. There is one block here, a pulley is kept, and this is M2 and this is M1. The important point to be noted here is, this is not touching the block. In the previous case also, if you can go back and see, it was not touching. If it was touching, now you have to consider one more force here. The normal reaction has to be considered. Maybe that's not going to make any impact in calculation because we are considering only the vertical direction, but the forces have to be considered for the calculation purpose. So here also I'm assuming that M2 is more than M1. In that situation, this will go down with acceleration A and this will go with acceleration A. So because the string is same tension will be there in the blocks. So let us write the free body diagram for M2. M2, it will be M2G and this will be T. It is going down with acceleration A. So this force will be bigger. So M2G minus T is equal to M2A, equation 1. And about here, you have to consider the components now, because let us say this angle is theta. So this is M1G. In this direction, M1G sin theta will be acting. So here we have to work with the components. So because it is going in this direction, so T force will be more than M1G sin theta, which is equal to M1 into A. This is my equation 2. So add these two, T will be eliminated. So M2G minus M1G sin theta is equal to M1 plus M2 into A. So A will be equal to, if you take G common, M2 minus M1 sin theta divided by M1 plus M2. So once you get the value of A, you can put it here and get the value of T. The constraint motions and etc. that can be a part of another video, because those concepts, some more pulley cases has to be explained. Let me do one more case here. When there is an angle of inclination on both sides. Suppose a system is given like this. There is a pulley here, and there is m1 mass, and there is m2 mass here. Okay, so this is alpha angle and this is beta angle. Fine. So in this situation also you have to consider the components m1g sin theta and here m2g sin beta. Achha, here we are considering alpha, no? So this has to be written like alpha. Okay. So here I am considering T and here T, because the string is same. So how do I frame the equation? I will consider that this side force is more than this side. So the final moment, see, either it will go this way or it will go this way. It depends upon the components. Suppose this component is more according to the angle, then it will slide in this direction. We are making that assumption here. So this is accelerating in this direction. So in this direction, net force will be m2g sin beta minus T is equal to m2a. This is my equation 1. And in this direction, because this is more than this, T minus m1g sin alpha is equal to m1a. This is my equation 2. Add them. So T will be eliminated. The unknowns are T and acceleration. Okay. So m2g sin beta minus m1g sin alpha is equal to m1 plus m2 into a. So a will be equal to, if you take g common, it is m2 sin beta minus m1 sin alpha divided by m1 plus m2. Here we can make one observation that if this component becomes equal to this component, actually there won't be any movement in this pulley system. Okay. So acceleration, there will be no movement when acceleration will be equal to 0. That means m2 sin beta must be equal to m1 sin alpha. In that situation, there won't be any movement in the pulley. So next concept we are going to talk about the contact forces. Contact forces, how to calculate them, contact forces. What is the concept of contact forces? So contact forces means, suppose you take a block, you take another block. Now these two are in contact with each other. So let us say this block is A, this block is B. So regularly here the weight is WB is acting down, WA is acting down. Let us draw the free body diagram. Here N1 normal reaction will be there, N2 normal reaction will be there. But apart from that, there will be a reaction between these two blocks also, because they are in contact with each other. So there will be equal opposite reaction also on the blocks. Now this R is called contact forces. Contact forces. So we have to, I will solve a couple of easy cases in this so that you understand the concept in applying the problem. So let me take a couple of cases now. Now with that cases, I am going to conclude this session, and some more concepts. These are all revision videos. Now these concepts are required for solving the problems actually. In part 2, I am going to bring some more concepts. Okay. So let us see a couple of small problems in contact forces. The problem number 1 can be like this. So I am applying a force 14, and this is 2 kg and this is 3 kg. Okay. So I want to know what is the contact force between these two. So I can write it like this. I will write the free body diagram for 2. So I will write it like this. So on the 2 kg block, 14 force is acting like this, and I will say some reaction is acting like this. If I draw the 3 kg block, the same reaction will be acting in the opposite direction. This is 3 kg. So both of them are going with the common acceleration. The first step is to find the common acceleration. Acceleration will be equal to total net force. So on this system, what is the net force? 14. 14 plus 3 plus 2. So it is 14 by 5. Alright. So because this is going in this direction, the entire system is going in this direction only. Alright. So here, what is the net force? This force is bigger than this force. That's why it is going in this direction. So 14 minus R is equal to mass 2 into acceleration. It is 14 by 5. So 14 minus R will be equal to 28 by 5. So R will be equal to 14 minus 28 by 5, which is 70 minus 28, which is 42 by 5. Okay. Now the same problem I am going to do with 3 blocks. Let us see 3 blocks. So the situation can be like this. There are 3 blocks like this. This is 5 kg, 2 kg, 1 kg, and we are pulling with 22 newtons force. So we have to find out what are the contact forces at these 2 joints. So the situation can be like this. First you find out the common acceleration, 22 by 5 plus 2 plus 1. So this is 22 by 7 plus 1, 8. So 2 4s are 2 11s are. 11 by 4 is your common acceleration. Now I'll draw the free body diagram for the 5 kg block. So it will look like this. Okay. So this is 22 and this is some reaction R1. Now the system is going in this direction. So it will be like 22 minus R1 is equal to 5 into A. A will be 11 by 4, which is 55 by 4. So R1 will be equal to 22 minus 55 by 4, which is 88 minus 55 by 4, which is 33 by 4. Now let us draw the free body diagram for the second mass. So second mass will look like this. Because R1 is in this direction, this R1 will be equal and opposite. And between 2 and 1 kg, a new reaction will be developed. But as usual, this also will be going in this direction only, because the whole system is going in the right direction. So here net force will be R1 minus R2 is equal to mass. Mass means 2 into common acceleration is 11 by 4. So this is 11 by 2. So R1 we have already calculated, it is 33 by 4 minus R2. So R2 will be equal to 11 by 2 minus 33 by 4. Okay. So this will be 4 to 2s are 22 minus 33 by 4. This is 11 by 4 minus. So even if you take this block for the calculation of R2, you will get the same value actually. Okay. So if you take this block also, you will get the same value. You can check that case also. So we are getting 11 by 4 we can just check it out. So suppose if I am taking this block 1. So block 1 only R2 will be acting. Acceleration is in this direction and it is 1 kg. So R2 will be directly equal to 1 into acceleration. So R2 will be equal to 1 into 11 by 4, which was your earlier answer also. Alright. So like this, contact forces problems also can be tackled. Okay. Just share your comments, how you did you like the video. If you like the video, please share it with your friends and all that. I'm trying to bring some revision videos for the benefit of the students, where I'm going to discuss about the concepts, and in subsequent videos I'm going to discuss about PYQs and some good quality questions which can help you solve the problems from this topic. You can also send me, if you want any particular topic, you can comment in the that comment section, and if the topic is good, and in my free time I'm going to make a video to help the students. Okay. You can also send your messages to the WhatsApp if any particular doubts are there, etc. Good doubts are there, I'm going to explain them, making a video about them. Okay then. If you like it, please subscribe it. My channel name is Law of Physics. Thank you very much.